Thank you for attending Computar's Vision Beyond Limits webinar. My name is Jonathan Hackney. Oh, there we go. My name is Jonathan Hackney. I will be your host today. I am one of the sales directors here at Computar, so I have a background in industrial engineering. I've spent the last 15 years of my career in the manufacturing and automation industry. So I've been an application engineer and seen countless applications, anywhere from 9mm rounds to babies' diapers. So I've seen it all. For more than 40 years, Computar Optics has been part of a global conglomerate, CBC America, and we've been the worldwide leader in developing innovative lenses. So with its technical expertise, Computar Optics consistently engineers superior optics and custom lenses. So that's if you're unfamiliar with Computar or CBC. So today, the agenda, we're going to do a little bit of intro into SWIR. That's why you guys are here. So we're going to talk about some SWIR. We're going to talk a little bit about NIR and thermal. We're going to go through all the different types of camera spectrums, and we're going to list out a couple of different applications. There are a lot of different applications popping up, so if you don't see your favorite one, it's okay. They are constantly coming up with new and innovative ideas and techniques to use SWIR in all different types of industries. So it's very exciting and very growing industry. So we'll talk about using SWIR. We're going to look at some of the comparisons between the different types of technology. I've got a demo video of one of our newest SWIR zoom lenses that we'll show, and then we're going to talk about some recommendations and what are some things to think about when choosing lenses or SWIR cameras for your application. And then we'll go into a little Q&A here as well. So first, we're going to talk a little bit about the intro to SWIR. So this first slide shows a couple of different terminologies that you guys are probably familiar with. You guys have heard it, but really I wanted to get down to the basics, do the intro for people who have no idea what SWIR is. So SWIR stands for shortwave infrared. And that's part of that bottom terminology. But first, let's talk about hyperspectral imaging. So hyperspectral imaging and multispectral imaging, these are terms that get thrown around. And for someone like me that gets kind of, that has dyslexia, I will have issues kind of remembering which one is which. But the main difference between the two is the number of spectral bands the cameras cover. So hyperspectral imaging systems, they acquire images in over 100 contiguous spectral bands, while multispectral imaging, they're taking a few narrow bands and they're comparing those narrow bands in the software that they're using. Multispectral imaging, it's useful to discriminate against land surface features and landscape patterns. Hyperspectral imaging allows for the identification and characteristics of materials. Next, long wave infrared, that refers to the detection of that infrared radiation between 8 to 15 micrometers. And then near infrared imaging, that's detection and visualization of infrared radiation within a long wavelength, typical 8 to 15. Use various applications such as night vision, thermal imaging, surveillance, remote sensing, and due to its ability to detect heat signatures and thermal variations. And then what we're all here for, shortwave infrared technology, it captures images in the shortwave infrared spectrum, generally around 1,000 to 2,500 nanometers. So SWIR, shortwave infrared. So some of the components of shortwave infrared. So the machine vision typically consists of the following components. First, you've got your cameras, right? So what type of camera are you going to use? Are you using a hyperspectral camera? Are you using a multispectral camera where you're getting single bands or a few bands and you're comparing the two? So definitely important. Lighting. So lighting is very important as well. That's probably the most important thing that I've learned over studying SWIR and studying this technology narrow band LED lighting, wide band quartz halogen lighting. Those are the types of lighting that you're going to need in order to give you that SWIR-y look. If you don't have the lighting and you just have the camera and the lens, what you're going to get is an image that almost looks identical to a black and white visible spectrum image. So definitely lighting is what's going to help you with that. Same thing with filters and bandpass filters, multipass filters. Those are also very important. Lenses, again, I'm the lens guy, so I'm going to say lenses is probably the most important. You have nothing if you don't have a lens that's going to be able to capture that infrared spectrum. So it's going to focus that light and give you that clear image. Then you've got your image processing software. So this is the software that some of your either third parties or all-inclusive guys are going to have for you guys. They're going to be able to look at your image, analyze it, analyze and extract that data from it. And then you're going to have computers and processors. These are the parts of the system that's going to computate some of those tasks and images and analysis and decision making. So that's also very important too. So let's look at the types of SWIR imaging. So we mentioned earlier SWIR cameras, those are going to specialize within that SWIR spectrum. We also then have hyperspectral imaging. So that hyperspectral imaging is going to carry a lot of wavelengths. Again, the hyperspectral is up to 100 different types of contiguous spectral bands. Next, we have the SWIR line scan imaging. So line scan cameras that capture in that SWIR. SWIR thermal imaging, so that's a combination of SWIR and thermal. And then SWIR reflective imaging, so that's analyzing the reflectance of SWIR lights from various applications. So those are different types. And you can see in the illustration above, you're going to see that illustration between visible and SWIR in a nighttime setting. So let's talk about how do SWIR lenses work. So first, you're going to have the material and coating. That's going to be the special coating that's going over the actual physical lens elements that are coated. They're coated specifically to transmit within that SWIR wavelength and minimize losses through reflection. Next, another very important is the optical design. So the design of the SWIR lens focuses on reducing chromatic aberrations and distortions, some of those ghost flares and infrared wavelengths for clear imaging. So that's also very important. Next is detecting and imaging. So SWIR lenses focus SWIR light onto in-gas sensors, in-gas detectors in the camera, enabling imaging and distinct SWIR characteristics. Next, the application advantages. So SWIR imaging is advantageous for seeing through opaque materials. That's why you use SWIR for your inside your lab type applications. SWIR is very useful in seeing through whether it be plastics, your hard plastics. So a lot of fill level, height level detection applications. Maybe detecting if the right product is in the right container without having to actually open the container. Almost like, think of it as an X-ray. It's definitely not replacing X-ray in the food and packaging industry, but it's very good complementation to X-ray. Other applications that you'll probably see, surveillance. I've seen a lot of surveillance, obviously, a lot of semiconductor inspection. That's the big one that's starting to blow up a lot. And then, agricultural monitoring. There are other applications, and we're going to talk a lot about some of those applications, but I've even come across actual communication. So physical device-to-device communication using lasers and using the SWIR detector. It's very advantageous to shoot through fog and smoke and stuff like that, clouds. So we'll talk more about this later. So the next thing I wanted to do was just break down what the current market covers in your CMOS and in-gas sensors. So this graph right here is showing that quantum efficiency of your typical CMOS and in-gas sensor across 300 to 1700 nanometer wavelengths. And as you can see, That CMOS sensor is going to be ideal for that visible wavelength. And that visible wavelength falls within that 300 to say 700 area. So that 300, 700, you're going to use a CMOS, CCD, other different types of those types of cameras. If you're going into the other wavelengths, to the 900 to 1700, then you'll see that quantum efficiency jumps and spikes for the in-gas sensors, right? So that's the main breakdown of what we currently have in the market. Now Sony comes out with this new image sensor. So this is the Sony IMX992 and IMX993. Even for me, it was very new, especially doing this presentation. Very new sensor. This thing just came out, I think, last month. It is a very high resolution, high performance imaging sensor. The IMX992 is 1/1.4 inch with a 5.3 megapixel, and the IMX993 is a 1/1.8 inch with a 3.2 megapixel. This particular image sensor is utilizing Sony's new technology called SWIR. SWIR is a wideband, high sensitivity SWIR imaging sensor technology implemented by the combination of compound semiconductors, the in-gas photodiodes, and the silicon readout circuits through copper-to-copper bonding. So that's what you see here in this illustration here, is that copper-to-copper bonding versus your typical bump bonding for some of those image sensors. So the top indium phosphorus layer inevitably absorbs some visible light, but applying Sony's SWIR sensor technology makes this layer thinner so that more light reaches the underlying in-gas layer. So the sensors have high quantum efficiency, even in visible wavelengths. So this enables broad imaging of wavelengths from your 0.4 micron to 1.7 micron. So now a single camera equipped with this sensor can now cover both visible and SWIR spectrum, which previously you needed separate cameras to do. So now if we go back to our quantum efficiency graph of the in-gas and CMOS sensors, we can now see where Sony SWIR's image sensor falls. So it covers, this triangle right here that is a huge value add. So it's a huge value add to the growing game-changing technology. So as a single camera can now do visible and SWIR imaging with that high QE. This reduces the system's complexity. So now no more dual camera setup, right? So now there's lots of potential interactions in the near IR and SWIR range to be explored as well with this new Sony sensor. Now let's get into the applications. So what are the SWIR applications? Well, there's a large number of applications being explored right now, and which include, but they're not limited to, military defense, again, targeting, identification, guided ammunition, also communication. So talking between, two outposts, maybe using direct line of sight with the SWIR. Second, industrial inspection, so quality control, material sorting. Third is that semiconductor inspection, so wafer inspection. Agriculture is the next one. Food and beverage, medical, scientific research. And so it keeps going on. The list is ever growing, right? Some other applications, counterfeiting, drug detection, art, photo, document, hologram, currency detection, and then, of course, your surveillance and security applications as well. So really what I wanted to do was first talk about what are the most practical, what are the most common uses of SWIR. These are all applications of where SWIR might be used and could be used and probably are being used right now. Who's using the most and where is it used in most? So the first would be your semiconductor inspection. So the silicon, it absorbs visible and infrared wavelengths, making it ideal for most imaging detectors. But silicon can't be used for infrared detection because it loses sensitivity past your 900 nanometers. So and it's transparent to wavelengths longer than, say, 1100 nanometers. So this transparency to SWIR enables imaging SWIR applications like photo emission failure analysis of ICs, or imaging of IC and MEMS layers for alignment errors. Another important application for SWIR cameras is the wafer inspection itself. So during the manufacturing process of wafers, particles may occur on the top, at the bottom, even inside the wafer. So whereas CCD and CMOS cameras detect particles on the top and the bottom layer, the InGaAs camera, it can see through the silicon, therefore detecting particles between the bonded wafers themselves. So wafer semi-inspection, definitely the number one top application. The next is going to be your plastic sorting. So here's an image that shows how SWIR can be used to inspect uh, uh, this plastic sorting and determine, okay, which one's PET, which one's PVC, and actually get to an efficiency. I've heard test studies having in recycling plants have a 98% efficiency using this type of technology. So the image camera, along with some analysis tools and analysis software, can then say pick apart and determine what plastics what. The next is food inspection. So here's an image that shows SWIR and how it impacts the food and grade inspection industry. So you could see, we could look at foreign object detection, quality control, we could grade the meat. So a lot of different things to do with SWIR. Again, we're not replacing X-ray whatsoever, especially in this type of application, but SWIR is definitely a very value add to them. So let's talk about using SWIR for surveillance, right? So visible versus SWIR. Shortwave infrareds, they're are effective at coastal monitoring because they can detect objects at greater distances than visible light and thermal infrared cameras. As you can see in this image, we could actually see through the fog, see through the smoke, see the boat clearly. So shortwave infrared, very awesome. Now, when you're talking about short infrared at night, so SWIR at night, then that's when things become a little bit tricky, right? Because what we're losing is our light source. Our sun has gone away, and so now the light source has decreased, and so the distance and how far we can see also decreases. So then for those type of applications, you would want to go into your your long wave thermal, that area. So again, what's best for your application? Is it SWIR? Is it short wave? Is it mid wave? Is it thermal? Is it long wave? So there are a lot of different benefits and a lot of places to explore. Some of the things that I've found while searching, NIR is really good. SWIR is really good, operating at that 780 to 2500 nanometers. A lot of what I'm seeing, some of the SWIR techniques provided in Vivo information, which was previously inaccessible. So by making use of its capacity to penetrate biological tissue and reduce attenuation, this enables researchers and scientists to dive deeper into atomic structure and physiological processes, molecular interaction. So using that SWIR, using NIR, you're going a lot of medical research has been able to take a lot of images that have been impossible since. So again, extensive research, commercial growth, and NIR agents. SWIR is very important key for large animal models and potential human use, but the development's limited by the lack of sensitivity detectors beyond 1100 nanometers. So those would be some of the main differences. And then also NIR fluorescent agents are preferred for that in vivo imaging due to low tissue absorption and scattering. So while SWIR imaging, same thing. And again, as you can see here, SWIR, again, you would use SWIR, you can use it at daytime. That's when a lot of times you use SWIR. And then at nighttime, again, you lose your light source. then you want to go to your long wave infrared as well and thermal as well. So a demo video of our new lens. This is our new reflex zoom lens, and you can see from the title here, this thing is 520 millimeters to 1300 millimeter varifocal length. So very awesome tool. So let me show you this video here real quick. So again, our reflex zoom lens, 1/1.8, so it's going to match that IMX 993, 990, or sorry, 993, and then your IMX 990, 991s as well. So this is actually using the IMX 990, and you can see at that 520 millimeter focal length, the difference between visible and SWIR. You know, visible, I got a lot of that haze, I got a lot of that either pollution, water, whatever it may be, it's blocking my view. With the SWIR, you're going to be able to shoot straight through all of that and get clear images. This is some other really cool. So this 2.5x optical zoom, so you can see how far away we can be and how clear we can get. Here's another one taken Japanese airport 11 kilometers away. So you see that difference, very clear between the visible. Visible is very hazy. You can see as that airplane pops up, really nice. So coastal observation or whether it be, you know, aviation, SWIR is very awesome. There's a wind farm right there, 20 kilometers. So now we're getting really far out. We can see very far. This is only at 520 millimeter focal length. So we haven't even utilized the full 1300, and we're looking close to 20 kilometers away. All right, so what are some of the importance in SWIR imaging? So lenses, you know, I'm the lens guy. I'm going to say lenses. Lenses can determine the spectral range. It also controls that image quality, right? If you don't have a great lens that's in that SWIR spectrum that has great resolution, your images are not going to be that great. So it enables that accurate spectrum analysis. So you could choose that lens based on the type of spectrum area that you want, in this case, SWIR. And other factors to consider, ensure that the lens is designed to capture a specific wavelength. Yeah, that would not be cool if you didn't get that one. And then focal length, aperture, those are things to think about, especially in your application. So here at Computar, we have a wide range of SWIR products. We have our VizSWIR Hyper APO series, and then we have our SWIR Light series as well. These guys fully corrected focus shift, so there's no focus shift with our Hyper APO series going from that visible to SWIR sensors. So now if you're using that IMX 992, 993, this is the lens especially for you. You'll be able to switch between that visible and that SWIR spectrum, and you won't have to jack with the focus as well. So not only do we have these guys in that fixed focal, we also have that zoom that we just showed you. But again, high resolution, low distortion design, designed for that 8.2 millimeter image circle format, so a 2/3 inch, and very small compact form factor. Again, this is some of the details of that lens that we just saw. I'm calling this guy Big Country. 520 millimeter to 1300 millimeter focal length. Again, it's in that SWIR range, that 400 to 1700 nanometer, IMX 990, IMX 991, and then IMX 992 and 993. Reflex zoom for super telephoto specs, and very compact, lightweight. It's got a mechanism for adjust back focus as well. So compact, lightweight. So now, if you guys have any questions, I have the SWIR. I'm sorry, SWIR. I got SWIR on the mind. I have the chat box open. Please send me any SWIR questions. If it's something I really can't answer right now, I'll definitely make sure to get back to you and get you that. Well, there we go. Macro version, minimal focal distance. Um, we don't have macro version yet, but it is something that we are looking into. Um, as far as the minimal focal distance, I can check in the specs real quick. Let me look real quick in this guy. If not, I can send it to you if I can't find it right now. I'd have to kind of look through these guys, kind of see. Let's see if I have it on the top. Sorry guys, it should have been right here. It's not here. Where are you? I got every other spec sheet but that SWIR spec sheet. Apologies. I can get back to you. I'm sorry, I'll get back to you, Mitchell. What is your price range of the lens? So this guy, see if I can bring it up here. So price range of the lens, the Hyper APO series is around 3,500 for the Hyper APO. The SWIR Lite it is a lot more cost effective. That one's around like 1,500 um, for those lenses. Now the big guy, I think that's a couple thousand, obviously. So I'm not exactly sure. I want to say it's around 20 to 25,000. You use a filter also for the examples when you're comparing both images. Javier, I'm not really sure if a filter was used. If it is, I'll get that information and I can send it to you. I'll make a note of some of these questions here. So I'll get back to you, Mitchell, and I'll get back to you, Javier, on that as well. Any SWIR lenses in the M12 mount? Currently, no, but that is subject to change, I'm sure. We are seeing a lot of movement in the M12 market. A lot of customers are coming to us for more M12. We're expanding some of our M12s is right. Um, we're expanding some of our M12 series as well, and it is possible in the future that we do come out with a SWIR lens that is for an M12 mount. Dino, Peter, whom should I write if I'm interested in additional details of fixed focus wide spectral range lenses? So that's a good question. You can definitely write me. Send me your questions. Here's my contact info. Please shoot me an email. If I didn't answer your question correctly, or if you didn't get a good answer, definitely shoot me an answer. Shoot me a question, and I'll go back to you guys. Shoot me an email. I'll get back to you guys with an answer for your questions as well. I'm sure are there any vulnerabilities to the IR code iPhones? Social cleavage. Again, that's a good question, John. I'm not exactly sure on if those solvents can damage the IR coatings on the lens. I wouldn't really use solvent, just a certain towel, but I can definitely find out more about those solvents, circle back to you on that as well to see what are, what should you clean with. Obviously, you don't want to get water in the lens or any kind of liquid in that lens inside the lens elements. They're not IP69K, so definitely try not to get any water in that as well. But John, I can find out more about some of those vulnerabilities in those IR codes as well. Says Kevin says need lenses to cover 400 to 200 nanometers using CQD sensor. Okay, I can certainly look and find you one. I know ours, like I said, ours is going to cover up to that 1700. If you're going to need past that 1700, I can look for you, Kevin. Shoot me an email, and I'll get on that for you. I got your contact here. All right, Kevin. Well, good. If you guys don't have any more questions, I appreciate your time. Thank you guys for coming to this webinar, and please shoot me an email if you do have extra questions, or if sometime in the future you do need some type of SWIR or even visible lenses. I'm the lens guy, so definitely come to me, shoot me a question, and I'll help you guys out.